In this unit, we're going to be looking at different types of diode circuits. Now, of course, we can't talk about every type of diode circuit because we don't have enough time, but we're going to hit some of the important ones that we see and used often in everyday applications. So the first one that we're going to talk about is something called rectifier circuits. So let's start by defining clearly what we mean by rectification. So rectification means that we're converting an AC voltage to a voltage with only one polarity. And so typically we're going to be talking about sinusoidal AC voltages. So that just means we no longer have positive and negative voltages, but we only have positive or only negative, but typically only positive. So converting an AC voltage to a voltage with only one polarity. Okay, so why is our rectification important? So let's spend a few minutes talking about that. So as we can kind of see, this is going to be one of our crucial steps when we're converting from an AC voltage to a DC voltage. Not the only step, but a very crucial one. So a crucial step in converting from AC to DC. So of course, if we're talking about a sinusoidal signal, we have maybe some AC voltage that looks like this, but we want just some constant DC level. So our rectification is a key part of that. So let me put up a diagram real quick that shows sort of the basics of this process of going from an AC voltage to a DC voltage. So if we think about the voltage that is available at a standard wall outlet, that's going to be an AC voltage source. So we have something that looks like this sine wave here. And so here in the US, that's nominally about 120 volts. In other places, that magnitude can vary. And around the world, it usually has a frequency of either 50 or 60 hertz. So what we have to do if we want to power a lot of our devices, first we have a transformer that's going to step that down. We then have our rectification. And then we see we have a couple other steps as well, a filter, voltage regulator. We'll talk about our filter a little bit, and we'll talk about another type of diode circuit related to voltage regulation, but we'll get into this topic a little bit more in a later class. And then on the far right, we have just some load represented by a resistor with some voltage across it. But again, we're going to be focusing on our rectification for these first few videos. And so again, why do we even want to bother with this process of AC to DC conversion? Well, again, we have AC, that's what's available at our outlet. And the reason for that is, of course, it's easier to transform voltages, AC voltages with AC transformers. The way that a lot of energy is generated, electric energy, we think about rotating generators, which inherently produce AC voltages. So for that reason, we have AC at our outlet, but most, or at the very least, a lot of devices that we use daily need DC. So everything from laptops to phones to computers, most small appliances are going to need DC. So oftentimes we need to have some type of adapter that will convert AC to a DC. And so we're going to look at two different types of diode rectification. So let me just write that here. So two types of diode rectification. And within those two types, we're going to look at different ways that we can do some of them. So there's not necessarily just two ways that we can rectify. So the first is going to be half-wave rectifiers. And so these are going to be simpler circuits. And the second we're going to look at, as you might guess, is full-wave rectifiers. And so these are going to be a little more complicated, but they're going to be more efficient. We're not going to be as wasteful in terms of getting rid of some of the power. So in the following videos, we're going to take a look first at our half-wave rectifiers. We're then going to look at a couple ways to implement full-wave rectifiers, and then we'll move on to other important types of diode circuits.